To wrap up our nitrogen discussion, we're going to end with something very specific, looking at corn nitrogen fertilizer rates and recommendations. As folks likely understand and appreciate, corn we have typically 5.5 million acres of corn planted in Ohio each year. It's the second largest crop next to soybeans. And corn is a very nitrogen-hungry, nitrogen-loving plant, and so it's a major input cost in terms of production. So we're going to deal specifically with corn nitrogen fertilizer because there's been a lot of work done on it, and it's a very economically important crop in terms of Ohio itself. We can start by asking, is there a relationship between optimal N rate and yield in corn? And very common thing to do in agronomy research anyways is to go out and put various rates of nitrogen down, total N applied in pounds N per acre, and then measure grain yield across that. And we might apply nitrogen at different times or whatever. We look for when that, we draw essentially a yield response curve. We see where that say these are two separate fields, or maybe the same experiment with two different, say, rates application or timings application, and we measure what the grain yield is at that given level, at that plateau, and then measure the nitrogen rate at that plateau. Okay, so we can and have done this many different times across many different fields across the state, and we can say we can combine all those data together into essentially one graph where we're looking at the grain yield versus the N rate. And what do we see here? Well, if we ask that question, is there a good relationship? The answer is clearly no. It's all over the place, right? And why is this? Why is there not a good relationship between optimal N rate and corn yield? Well, there's a lot of reasons. Part of that fact is that corn, again, is this leaky dynamic nutrient. But the other part of this is that production potentials can vary greatly. One field might, for example, yield poorly and still need a lot of nitrogen to get it there. Some fields might yield very well, but just need a little bit of nitrogen to get it there. So it really depends on the year. It depends on, each individual data point here is a field trial that has its own unique story to tell. And so the old approach was to go out and say, okay, I want to raise 200 bushel corn. I need to apply this much nitrogen to get it there. And this really isn't a philosophy that we embrace anymore. We know that it's not really a great way to manage nitrogen, especially in corn production. So several years ago, a decade or more ago, this idea of maximum return to nitrogen was born out of these meetings between soil fertility specialists in the Midwest. And they all recognized that there wasn't a great relationship between how much N you applied and how much yield you got. I mean, there's a general relationship within any given field season, but thinking about from a statewide recommendation. And so the idea here is that we need to move towards an economic model, because depending on the year and depending on what corn is going for and what nitrogen fertilizer costs, we can have large differences in what that nitrogen rate might be. All right, so this is a publication, the links right here, that kind of outlines some of this framework. If you're interested, I think it's an excellent guide in terms of, if you're interested in nitrogen in corn, this is a great place to start in terms of thinking about the needs of nitrogen in corn and developing N rates, and how do we go about this? How do we form a rationale for developing N rates? Okay, so economic model is better than yield goal model, i.e., I want to grow 200 bushel corn, so I need to apply 200 pounds N, right? It's better because N demand varies from year to year, and that applying rates on yield goal does not consider the price of N fertilizer or the price of corn. We know that corn prices have fluctuated greatly over the last decade, and nitrogen prices have fluctuated as well. And so, if we really want to, run a profitable business in terms of growing corn, we need to be looking at maximizing profitability, not maximizing yield, and that's the whole idea with this. Okay, so this is a very simple tool, MRTN, or maximum return to nitrogen. That return means essentially for every additional pound to N, are we going to see a return on that investment or not? And so it's not a model that tries to minimize nitrogen loss. It's not a model that tries to maximize corn yield. It's a model that tries to, again, maximize economic return. The model is very simple. It requires really just a few inputs. The typical yield response to corn to nitrogen, that's something we generate over many, many field seasons and have a kind of a statewide average for that. And it looks at the cost of nitrogen fertilizer and the price that we assume we will get for that grain. So as the price of nitrogen increases, our fertilizer rate, our maximum return nitrogen, is going to decrease since the overall input costs are increasing relative to the return. Conversely, if the price of corn increases, that recommended N rate will increase. Okay. Here's the website. It's an Iowa State hosted website with these states: Ohio, Indiana, Michigan, Illinois, Wisconsin, Iowa, and Minnesota all participating. All of the data, it's an Iowa State hosted site, but all the data for the respective states have been generated in those states itself. Okay, so it's regionally calibrated in some regards. Okay, so the pros is that it's very simple. Again, it accounts for these three things, but it doesn't account for a lot of things. This is like essentially a broad brush to try to develop N rate. So we ignore the source, the type of N fertilizer, how it was applied, when it was applied. We have essentially totally ignore weather effects and the influence of weather, mostly precipitation, on N mineralization rates and N losses. We ignore previous management history, soil N mineralization potential. We typically ignore soil type and properties. Some states are subdivided. Ohio, as it stands now, is just a single state. And we also ignore within field variability. These are all potentially large sources of variability that might make this recommended rate, quote unquote, wrong. But again, it's the simplicity of a model and trying to do this over an entire state basis. So there's trade-offs when we're trying to develop these types of tools to help farmers. Okay. So we did a major update in 2008. If you're interested, there's a corn newsletter that we wrote that outlines that work. Here really is kind of the price of N fertilizer and the recommended N rate. So we've got price of N fertilizer in dollars per pound, so anywhere from 30 to 50 cents per pound. It could be higher, of course. And the price of bushel per corn. A price per bushel of corn. So this is $3.25 per bushel. A bushel is 56 pounds of corn. Typically trading somewhere between $3.50 and $4 last few years. $3.50 and $4 the last few years. And we've seen it as high as $7, $8, even just maybe 10 years ago. So that price can fluctuate dramatically depending on supply and demand. And you can see that when grain prices are low and nitrogen prices are high, we're recommending very little nitrogen, 155 pounds of N per acre. But when fertilizer prices are low and grain prices are high, it goes up to 200 pounds. So there's a 45-pound difference. And so this is all based in real-world data. So let's kind of get into this model, okay? And I'm just going to flip over right now and show you the tool in real time. So you come here, again, it's an Iowa State website. You can get to the tool via this link, go.osu.edu, corn, NRate. That's just it's just a redirect to this website, especially specifically. So we can look for nitrogen rates from single prices or multiple prices. Let's just do with a single price here. We're going to select the state, which is we'll do Ohio, and then we've got to select the rotation, which is corn following soybean or corn following corn. We'll do corn following soybeans because that, of course, would be our most common rotation. You can pick the nitrogen fertilizer type. It doesn't really have any bearing, but it just auto-populates a price per ton, or you could look at it a price per pound. Say we're paying here it's 40 cents per pound, or maybe it's maybe we got a good deal and it's 35 cents per pound, and here's the price of corn. And so maybe we're hoping to get $3.65 this year per bushel. Okay, so again, here's our units, dollar per pound. So you can either manipulate the dollar per ton or dollar per pound, whatever, and the dollar per bushel. And then we hit this calculate button. And it's just going to send us, and again, here we see the state is Ohio. The number of sites is 228. So we have 228 nitrogen rate sites that we've conducted over the last 15, 20 years across Ohio. This is a lot of work, folks, so it's a big investment in energy to try to, kind of determine this. Here's our N price corn, our MRTN. So this is our maximum return to nitrogen, which is in pounds of nitrogen per acre. This is our N rate, our recommended N rate. And then here's this profitability range that basically says if we're paying that much for corn and getting this much for grain, anywhere between, this range is going to make our N rate profitable. We're going to actually make money doing this. Of course, a lot of assumptions in that. Here's our net return to nitrogen at that MRTN, 182 pounds, $218 per acre, etc. So how does this work? Let's get into here's our green is our N fertilizer cost. That's a fixed input cost. Of course, there's other costs that farmers have to pay and use to grow grain, but this is a major one, right? It's seed cost for corn, and then typically nitrogen fertilizer costs 1 and 2 in terms of the number, the highest input cost. If you're paying 100 pounds of nitrogen, that's essentially at 35 cents a pound, that's going to be $35. And then that's going to increase. So if our nitrogen fertilizer price is high, the slope of this line is going to be greater. Or if it's cheap, it's going to be shallower, right? Our blue line is our gross return to N. So the gross is what we actually get for it. It's our yield response curve multiplied by what the price of corn we're getting on a per bushel basis. So our y-axis, our x-axis is our N rate in pounds N per acre, and then our y-axis is net return to nitrogen in dollars per acre. So this is our gross return. And if we think back to economics, or if you ever had an economics, of course, gross means what you actually it's what you actually get, but it doesn't include your input costs. So, gross is your total, and then but we actually need the net. The net is the gross minus the input. So what we get out of it minus what it costs us. Okay. And this red line is that's the net, and that's what we need to think about for profitability. So we subtract our input costs of N fertilizer minus our gross, and this is showing us how much N we actually our dollar return, and it's precisely at where this line plateaus or peaks is our price point, and that's going to determine our N rate. Okay. So again, we just had our inputs were 35 cents per pound of nitrogen and 365. Well, what happens if we come back here and say N fertilizer becomes very expensive. And so that goes to 50 cents a pound. And then we go and calculate this again. Or our slope is bigger, so our inputs are larger. Our gross essentially remains the same, that response curve. We didn't change what that is, but we subtract the fertilizer cost, i.e. our inputs, from our gross, and now that line peaks out at 162. Okay, so we can manipulate the fertilizer price for that slope, or we can manipulate the grain price and get our our gross. So let's just go back for the sake of doing this and say there's a big drought or something crazy happens. There's a huge demand for ethanol. Congress passes legislation that says everybody's got to have 50% ethanol, and it drives the price up to $10 per bushel, right? Well, guess what happens to our MRTN then? Because we're getting so much back in terms of this gross, and we subtract our inputs, and it's jacking this MRTN rate up to 214 pounds N per acre. So this is a dynamic model, and it's going to change based on inputs and outputs, how much you're paying for fertilizer, how much you're getting for corn, and that's the whole point. Okay, so we can also look at multiple time points, and there's other options that you can think about, coming over. So it's actually kind of a sophisticated tool, but the nice thing is very simplistic. Now, you don't even particularly have to go to this website to do this, right? I just showed you essentially these different scenarios based on the price of corn and based on the bushel per return. And this is all for corn following soybeans. So if it's corn following corn, then these prices are gonna differ. Okay, so what an N rate requires. So we're going to kind of take a step back and think about what a typical N rate would require. Well, we need to think about a lot of things. This is a very simple model, and it doesn't include everything, but the beauty of it is in its simplicity. So it's not, I'm not going to stand here and say it's perfect in any stretch, because we understand that N rates require soil type and soil properties. We need to consider those. We need to think about management history, right? If you've got like a manured field with a high organic matter, that's going to be very different than a field that's just been continuously cropped without any input. Weather effects have tremendous impact on production and availability and losses. These are the types of things, we already kind of went over this. Well, there's tools that are out there that are trying to consider all these types of things, okay? And instead of just a simple free MRTN model, there are these crop sensing or kind of whole crop picture things that are out there, right? So we've talked about Green Seeker, and there's other things like Optec. There's a lot of money, of course, in growing corn, and there's a lot of people trying to crack this nut in terms of figuring out the perfect nitrogen rate. And it's challenging, but incremental steps are being made. So there's sensing approaches that are out there, and there's also these modeling approaches that look at dynamic modeling of N availability and losses. AdaptN was really the first. This was developed out of Cornell University. There's also Mazen, there's Climate Corp, there's Encirca. The Climate Corp is Field View. And an organization recently in Ohio did a evaluation of these products, specifically AdaptN and Field View, okay? And unfortunately, they did not really fare particularly well. And again, here's a link that shows some of those results if you're interested. Again, this is not something that I'm going to be required to test you on, but if you are interested in kind of digging into this, there's a lot of promise with some of these software packages. These are typically web browser cloud-based packages that pull in. You define your field, you define your N rates and some of your management history, and then it makes a bunch of assumptions and pulls in soil data, pulls in weather data, and helps you kind of dial in your N fertilizer rates. But it's all for a fee. And then, the question is are you actually getting valuable information that's calibrated to Ohio conditions? And these models are constantly getting tweaked and adapted, but at least the last few years they haven't done a very good job. So anyways, I will, we've got a long way to go. I'll just end with saying we've got a long way to go with kind of quote unquote figuring out that perfect N rate. There's lots to be said about it. I've probably talked too long already. I'll end here and say that this MRTN is I believe, a simple tool that helps growers get in that ballpark range. Right? It's not going to be perfect every single year, but it's going to help hedge your bets and get you to be in that profitable range for growing corn. So that's the whole idea.